I want to spend my life going on a long journey, rewriting the semantic model inside a building, which prepares it to interoperate with new engines.
Welcome to the AAC Tech Series. Today we meet Richmond, co-founder of Modumate, a design platform that seeks to revolutionize how buildings are designed in 3D and automates the most time-consuming and tedious tasks, drafting and documentation. So let's meet the person behind the vision and learn a totally new way to design and assemble buildings in 3D.
Background is that I'm a licensed architect. I've worked in 7 firms on about $4 billion of construction. I did a lot of high-rise multifamily stuff. I did quite a bit of like a luxury single-family stuff. I worked on some interiors, both coasts. Technically worked in Pittsburgh, Pennsylvania as well, although most of my career during my time at CMU roomed with 3 computer scientists and was kind of really always aware of those issues. One of them was focusing on video game development, and he remains my best friend. So he, back in those days, was teaching me about kind of why video game engines can perform at the levels they do, while I was learning to kind of use old clunky CAD tools and the semantics of architecture. And so ever since I kind of dropped into the workplace, I was suspicious of the amount of drafting labor that goes on, the document production process, and how distinct that is from the design process. First image I ever made that ended up giving life to the ideas of Modumate was this image, which I've now wrapped in some other language. But this image, throughout my career, I was suspicious of everything in red on this page. I think of architecture as having 2 types of work, and the first is choosing and composing the building's parts. That's done in green, no matter what software you're using, AutoCAD in this case, or Revit, or ArchiCAD, or Rhino, or Chief Architect, or Vectorworks, SketchUp, whatever you use, it is choosing and composing the building's parts, like actually depicting this door and how wide is it and where does it go and which direction does it swing. Those are decisions that leverage your expertise, which the client values, which you enjoy. The green phase is the happy phase. Unfortunately, it constitutes a minority of time spent in architecture today. And the red stuff, which is you unpacking your old decisions and having to repeat yourself to make yourself legible to a permit official or a builder, that is the kind of much more time-consuming step and something I think computers are much more equipped to handle. So I spent kind of 2013 through 2017 collating, and earlier than 2013, but my kind of 4 years of really in the trenches professional design experience, collating reasons why we ever make these red markings. And I came up with 180 questions being asked by the International Building Code or general contractors about any given building, and 120 mental subroutines that draftspersons go through to answer those questions. Before Modumate began, I assembled a list of 120 drafting algorithms, which if there was an information model that could be traversed to basically automate the process of describing your exterior wall partition junctions, your exterior wall openings, your floor, projected floor areas like a deck that did not pass the cut plane, your et cetera. Dimensioning is probably the richest category. Tagging is next richest. And then sheet pagination and assembling drawings on sheets is kind of the next biggest category. And they go down a list. But what we did in 2018, I kind of found my co-founder who was deep in the gaming space. And his name's Jason Schenkel, 21 years my senior, spent 15 years building The Sims and SimCity game franchises. And when I met him, I was like, thank you for my childhood, first of all. And also, I think that there is a product that could exist here with the information architecture an architect needs to automate drafting, but the technical architecture of a video game. And by the end of our first call, we were nicknaming it The Sims Pro and calling and have chosen Unreal Engine as the kind of shortcut to easily get a performant 3D app built, although all of the semantics are ours proprietarily. So automating drafting is our longest term vision. And I think of it like 3 acts where we had to design the semantic model. Act 2 is where we can finally, and last week we released Modumate version 3, which includes our first drawing designer tools, the environment in which drafting could be automated for producing plans, sections, elevations, details, blah, blah, blah. And so we've become now a documentation tool, although that feature is kind of in beta, going to take a year to iron out its kinks. We now are in parallel able to start releasing these algorithms. And then that's Act 2 of automating drafting. Act 3, when architects are not doing the red stuff, just the green stuff, is to introduce first-class building performance improvements that allow them to do the green stuff with as much empowerment as possible. So flipping you through another 5 slides in rapid succession, the 5 innovations we think we're bringing around this project are that it is real-time multiplayer. Up to 16 people can currently see themselves in Modumate, the avatars of the other players orbiting in 3D, the actions they make as soon as they make them. That is already complete. A deeper semantic model for how the parts inside of assemblies connect together and are arrayed in space. That logic, finally, a language that can describe every type of stud layout that a builder cares about, or every type of design patterning. The hierarchical language we've come up with here is actually like HTML and CSS for making websites, where you create kind of a box model of regions and then can pattern things in those regions. The hierarchy can be arbitrarily deep, and they can be applied to polygons instead of boxes. So it's like a polyhedral HTML and CSS that we've designed, but it goes deeper than Revit, which is very pancake-based, very much likes to be vertical, doesn't even know what a stud is. And as a result, we're already keeping track of the parts in your design with an instant quantity estimate to a much greater fidelity than Revit offers. And these parts and their connections are the substance of what drafting is all about. So we think that this model is going to finally be the bed on which drafting can be automated with enough nuance to really hit kind of what architects are looking for. And then the other two value props are really simple. Unreal Engine's pretty, much prettier than existing design tools, and obviates the rendering step for many less discerning users. And then lastly, the user experience is much more friendly and easy to grok. So most customers who felt like the 3D BIM ship passed them by are looking at Modumate with fresh eyes, realizing, wow, I can pick this up with just a couple of training calls from Modumate. So those are the innovations, I'd say: multiplayer, better semantics, automating drafting, gorgeous, and good UX. And then my previous sentence about how after drafting's automated, what will we do with our time? I think we have the opportunity to be the first design platform that accesses this future greenfield without drafting, where we have a lot more time to be considerate of what design is. And I developed a thesis during my time sustainability consulting that buildings are really just an optimizable filter for their occupants. Their only job is to deliver comfort, in the very broad sense of comfort being, the five senses, or some kind of psychological comfort, or some kind of programmatic fulfillment, comfort for the occupants. And to achieve it, they must consume resources. And the only equation is decrease the resources and increase the comfort. And so I think there's about 25 different parameters about building performance that could be studied. The types of resources are not just energy and carbon and water, but instead also time and labor and money and waste. Noise also is a waste output. And then with comfort, I mentioned all five senses. I think that includes things like touch, things like navigability, defensibility of space, biophilia. There's several psychological senses worth talking about. So that's the equation that kind of drives me in the 10-year time scale. But in the 3-year time scale, we've been building the semantic model. In the next 2 to 3 year time scale, we'll be automating drafting. So I'm orbiting and panning and zooming around our canvas. Modumate is a locally installed piece of software. We are upgrading the infrastructure to eventually build it into the browser, but Unreal Engine really works best when it has local access to your graphics card. So, and most architects are used to installing local software right now. So there's not really a need with our current user base to go browser-based. We're currently serving kind of the long tail of small architecture firms, much more than the big firms. If we wanted to spread virally through Gensler, we would probably need to be browser-based. But we're not ready to support Gensler-sized projects yet. So because underneath this model, there is a polyhedral graph, this massing graph, and this graph does a lot of computation every time you change it. And we need to make that more optimal before it supports buildings that are 500,000 square feet. So I think 50,000 square feet is kind of our max right now, which makes us suitable for a long tail, not so much for kind of downtown development. Their avatar flying in space as they move their camera around, you can tell from what room they're in or from what vantage point they're doing their work. You can see their cursor as it hovers around. You can't see pending actions. If they were trying to commit a line like this, but they hadn't clicked yet, you don't see that. You do see their cursor moving in real time, and you can infer what they're doing. And as soon as they click, that line shows up on your screen. So before you can commit any more actions, there's a central server that is negotiating at all players, up to 16 players. And every time somebody submits a delta, a change to the document, it performs that request gets submitted to them. That server affects the final document, and then checks out what the final document looks like and tells all players what the document looks like. So there's a couple of technical approaches to the way multiplayer works. And with a document this interdependent and connected, you can pretty much only use that model. The other ones available are for like shallow text editors, where the location of some characters and the locations of others are very independent, not connected in a graph-like way. Then you can use things like conflict-free replicated data types, which is what Figma does. But here we've got operational transform as our only multiplayer paradigm that works for us.
The longer term vision, have you started to look at the full cycle of the building from design to construction and interaction between the built project and the digital project?
So we have a lot of data about the construction of the building that Revit might not have. So I would say that of our current active user community, about 60% are builders who appreciate the rigor of our semantics and like our quantity estimates, and felt that the old 3D BIM tools were too onerous to learn. So there's a kind of an untapped market of users in the build side that we're seeing a lot of fit with. And so in that way, we're kind of sowing some seeds towards the downstream construction process, where they've noticed the clarity of this 3D, the literalism, the realism, makes it very, very clear to my build team what to build. So in terms of 3D mockups on site, we're finally able to use 3D, not 2D. And in terms of if I open up what these walls are made of, we take a look at this wall's definition, we end up seeing the layers inside the wall presented here in a very easy to grasp way. And then the layers themselves have a module that can be designed and a pattern by which they can be arrayed. And that translates into the quantity takeoffs. So, and when it comes to things like sheathing, you can also design the length and width of the board as well as its thickness, so that you have the ability to get an estimate of not just the total square foot of sheathing, but we preemptively do the division for the user of this is how many boards you're going to have to buy. We don't calculate the number of cut boards or loose ends, etc. But in a rough way, this is like that without them having to go through their hand drafted takeoffs and then post process those areas into divide by board size. We take care of like 95% of the labor, and then they already, after doing that step manually, are still stuck with a number that does not observe cut board sizes and has to go count those. So they're finding that we map very, very well into their workflow. And so in terms of kind of going down the construction value chain from design, I think that by working with those users and getting a brand that is well established with builders, we are going to end up having a good amount of upstream penetration abilities to architects and downstream abilities towards homeowners. Right now, where the digital twin ecosystem is very focused on like commercial real estate and building operations and maintenance, where the professional entity doing the managing. And I think that Modumate's tools are going to be very, very rich for those issues, in that we have the fully semantic digital twin of what's attached to what, with what types of structural rigor, and what are the parts inside, compared to some kind of a digital scan where photogrammetry gives you just the skin of the building. There's a lot of labor to convert a point cloud scan into a Revit model, and I don't know if there's going to be an easy path to making those point cloud scans become a Modumate model. I don't necessarily think so. That would be a eureka of computer vision to interpret a point cloud and figure out what the walls are made of. But I do think that getting a model built is much faster in Modumate. The depth to which you can represent semantics is deeper than Revit. And for the longer tail of people who are not already kind of used to a Revit-esque workflow, this is going to unlock the desire by homeowners for a digital twin they can keep up to date with, as 5 years later they want to revise their home again, or something like that. Excited to go up and down the value chain, but it's, I think, a simpler world than a commercial space. These cut planes that I'm using right here are able to export DWGs to AutoCAD. You can create as many cut planes as you want and export them all. And so it essentially is the 3D brain that coordinates a 2D drawing set the same way Revit does within its own sheet space. But for the users who never used Revit, this can supply the same time savings for an AutoCAD workflow. And builders tend to use AutoCAD more than any of those 3D tools. And they're also, because they make their money building the building, they are less discerning about the quality of the drawings. They're willing to kind of hack something together just to get the permit minimum. Look at whatever the list of requirements is the city requires. Do not scope past that. Handle the rest on site. That's the philosophy of builders. I find it really refreshing compared to having to focus on 60 or 70 interior elevations. There's really no substitute for an architect being overly thorough with their drawings, that they're going to be overly thorough with their design. Those have the right tool chain to fit with us and also need less rigor in their drawings. So this is a documentation platform where if they invest in getting the right details between the layers of their walls, they can reuse. In fact, that detail is governed at this edge. There is a roof detail here that controls the extensions of every layer in the 3 assemblies coming together. And this recipe for an extension, if I were to retract my studs, for example, I could go to my roof, I could find my rafters, and instead of 27-30 seconds, I could go -5 inches. And I do, I've just taught the top of the stud layer how to stop 5 inches short of the the massing edge that we saw just a second ago, the massing graph's edge. And I can retract this to -6 inches. And now I'm kind of controlling how these layers extend. If I go back to, 27-30 seconds, I'm putting it back where it came from, -29-30 seconds. So it's a bit of a silly, unsemantic mess of numbers right now, and we're working on making this more like target the neighboring layer and always bond to it kind of linkages. That's part of our summer projects. But the benefit of detailing here is that you are able to reuse this edge. What's going on? There we go. You can reuse the recipe you build for this edge at every other edge where the same participants come together. And in fact, you can promote these details to being typical, where as soon as those participants find that relationship, they default to extend their layers this way, so that you can get a model which is detailed in 3D and only design it one time and propagate it everywhere, which we think is going to be powerful for making models realistic, but also then you can automatically spit those details into the drawing set and just build a detail sheet every time somebody's designed one of these things, plop it in, and when a cut plane passes through that edge, automatically bubble the detail call out. So detailing in 3D was another piece of the semantics we've deepened, is the relationships between things. And architects are finding it refreshing that they can get this done in 3D, not have to detail every junction of a wall section here and down the way. Builders are like, oh, I kind of, like, it's a lot of buttons to click. I don't know if I'm always going to go down this depth here, but the fact that I can convinces me this product is professional grade. In the first couple of years of Modumate, I was the only architect on staff, and certainly I was just asking architects and working on my own projects and developing a kind of vision for what's going on in a construction detail. I think of there's actually being 3 types of relationships. There's the extension of the layers, which looks like I never detailed this edge here, but I will just quickly fix that. The studs here should be at 0 and 0. The studs here should be at 0 and 0. And there we go. Great. And I'll call this, I don't know, interior wall at roof, and I'll make it typical. Okay. Class of errors. So I realized that there's the extension of layers in each of these assemblies. Architects think in terms of assemblies. You got walls, you got roofs, you got ceilings, etc. So some collection of layers are bound together, and the architect says it's very likely I'll always use these together as an assembly now. And then those assemblies have layers that need extending. Extensions are one class. Another independent class is the offset of assemblies with respect to each other. The fact that you want certain faces to flush out together is technically a different math. One does not depend on the other. They're independent problems, but they're conflated in an architect's sense of a detail. And the third thing is the presence or absence of accessory materials. So things like caulking and backer rod, or like casing beads for one's plaster, other things which an architect doesn't really think about at the macro scale when they're out here. But then when they get in, they start to think about, oh, I do want to add in some kind of a gypsum stop or some kind of an expansion joint or something like that. So those 3 things ended up untangling as the major parts of a detail that are independent choices. And I got to that decision from 60 or 70 customer interviews. And I think by sharing the questions with the engineering team liberally and get them helping educate me on what a polyhedral graph can and can't do, we figured out where the right place in the model was to hang these decisions. Some people may not have realized that this edge acts not just as a boundary for the wall and the roof, but actually as the junction where they all meet. But graphs have a lot more connectivity awareness than you first give them credit for. So, we're talking about whether or not the edge is the right place for a user to think about that detail as living. We're also evaluating a world where you can just cut the building and then turn on detail view mode, and suddenly your model is crawling with little extension handles. And you just pick the objects and never really think about the fact it's the edge that's actually mediating their neighbor relationship. Instead, just think from the object outward. There's kind of, always going to be some adjustment as we respond to our markets. We ship features, they react, and then we counter-react. It's a key thing about Modumate is you can't sculpt the parts as much as you could in old software. We are not encouraging users to be able to, draw custom sweeps and extrusions and like make their own shapes from the ground up. Instead, we want to supply them the library of assets that are better than they've ever been able to sculpt on their own, and grow that library in response to their asks. The built environment organizes at various levels, from vertices into parts, from parts into assemblies, assemblies into rooms, rooms into buildings, buildings into neighborhoods, etc. Architects' tools today encourage them to sculpt the vertices into parts far more than they are the expert authority on the part. Having to resculpt the door handle, having to resculpt other things like that is a lot of wasted labor. And where architects and builders really want to be talking is at parts into assemblies and assemblies into rooms. So you've got tools like TestFit out there that are optimized, algorithmizing the rooms into buildings question, or buildings into sites question, the actual place where construction takes place, so parts into assemblies and assemblies into rooms level. So that's where we focus our semantics. Users do not sculpt parts. Users just have an increasingly rich way to connect them. And I think that we are going to include quite a bit of generative design insofar as the deployment of parts into assemblies is a sweet spot for us to make rules-based parametric assemblies. Generative design has been labeled at the higher levels of lay out my classroom in an intelligent way, or fit my building onto the site to maximize buildable area. We have the generic library of mixes. There's one identity of what a 30-day 3K PSI concrete mix is. Anybody who wants that mix maps to it. Anybody who vends that mix maps to it. So you aren't having to design from 30 redundant user-generated mixes floating around in the library. There's a harmonization of the UGC that has to happen that Revit never did, SketchUp never did. The 3D warehouse is poorly curated, BIM objects poorly curated. The metadata has to be made consistent amongst all of these entrants. If you want to start uniting the carbon coefficients or uniting the cost parameters, you can't call them $ and price and cost as properties. You can't have Revit's level of extensibility to the metadata. So we want to be that central vendor, but we also want to take a more active role in it, which is not going to make it an easy process.